Using integration, find the area of a circle x square plus y square is equal to 36. As given circle is here, x square plus y square is equal to 36. As this is the equation in implicit form, we have to separate y in term of x, that is in explicit form of y in term of x. So we separate term of y square. On right hand side we get 36 minus x square. So taking square root on both sides we get the y is equal to, as there is a subtraction, we take root of subtraction, that is root of 36 minus x square. Put it as number 1. As given circle is a standard circle, so radius of circle, by comparing this circle with equation x square plus y square is equal to r square, we get r is equal to here 6. So we plot the here the circle in coordinate system having center at origin now, and this is the radius on positive x-axis which is at 6. So parallel line or tangent to this point with respect which is parallel to y-axis, having equation x is equal to 6, and the equation of y-axis is always x is equal to 0. So as from figure we observe that the total area of circle divided into 4 parts. I shaded the bounded area which is from 0 to 6 bounded by curve with respect to x-axis, and so from figure we get required area A is equal to 4 times area from 0 to 6 bounded by curve with respect to x-axis. Now by putting 0 to 6 as y in equation 1 is root of 36 minus x square with respect to x. As we know the form of root of a square minus x square, having integration x by 2 root of a square minus x square plus a square by 2 sin inverse x by a. Here a is a 6. So by 2 into part, in first part variable x divided by 2 into term root of 36 minus x square plus a square is here 36 by 2 into sin inverse of variable x divided by radical is here 6 from 0 to 6. By putting upper limit we get upper value of integral in two part. In first part, as see 36 minus x square is x is 6 is upper limit, 6 square is 36, 36 minus 36 get 0, if the term will get 0. And in second term 36 by 2 is 18, and actually sin inverse of 6 by 6 is 1, that is sin inverse of 1 is always pi by 2. So upper value of this term is a 0 plus 18 pi by 2 minus lower limit is a 0. Lower value of first term is a 0, as it is contained term x in product, as x is 0 it remains 0. And in second term also, as x is equal to 0, sin inverse of 0 is always 0, so we get second term as a 0. Now simplifying this we get 4 into product of 18 pi by 2, that is 4 into actually 18 pi by 2 is a 4 9 pi. So required area is a 36 pi square unit. As you know, area of circle is have a formula, A is equal to pi r square. No, pi r square, as r is equal to 6, so answer is a 36 pi. Now we used this formula, but we have to find here using integration. So we evaluate by using integration. Total area of circle is a 36 pi. Next example, using integration find area of 9x square plus 4y square is equal to 36. Here given curve is a 9x square plus 4y square is equal to 36. As this is a equation in term of quadratic form of x and y, so it may be equation of a circle or ellipse. But this is equation can't be equation of circle, as we know coefficient of x square and y square must be equal for equation of a circle, as here they are not equal. So this equation may be in form of equation of ellipse only. As we know standard form of ellipse is x square plus a square plus y square upon b square is equal to 1, where a is a major axis of a ellipse. Now converting this equation in a standard form, we have to make on right hand side equal to 1, so that we divide 36 on right hand side, as this is equation, so we divide on both sides. As on right hand side there is addition, so we divide 36 each term. As in first term 9x square divided by 36 we get x square by 4. On second term dividing by 36 we get y square by 9. and right hand side we get 1. Now this is a form of standard equation, which is a equation of ellipse. As this equation of ellipse has a term a square is equal to 4, it means major axis is the root of 4, that is 2. But we have to find the area of this ellipse using integration. So we convert, as this is an implicit function of x and y, to explicit form, that is y in term of x only. So we separate first y square by 9 on left hand side. On right hand side we get a subtraction of 1 upon x square by 4. Now by taking subtraction on by cross multiplication we get 4 minus x square with denominator common 4. Now y square can separated by 9 taking on right hand side. Now it is in denominator, so we take in numerator in multiplication of 4 minus x square. So we take 9 into 4 minus x square. As 4 is a constant which is a common, so we can adjust in multiplication denominator. So we adjust it in denominator of 9 only. Now there are two terms, first is 9 by 4 and second term is bracket which is in subtraction. Now taking root on both sides we get y on left hand side, but on right hand side as there is a product we can separately take square root as we know. So root of first term is a 9 by 4 is a 3 by 2, and in second term there is a two terms but which are in subtraction, so we can't take separate terms square root, so we take root of subtraction. Therefore we get root of 4 minus x square. Now put this is as number 1, as this given equation is converted into form of explicit function to evaluate required area. Now as this is a standard ellipse, as we know the major axis is here 2. If this is a circle, then we define its radius. We now define here major axis of a circle by plotting this ellipse, as it is a standard ellipse on a xy coordinate system. We define here the ellipse has a major axis is equal to 2, so the tangent to the ellipse, the point where it cut the x-axis, has the equation x is equal to 2, as it is a parallel to y-axis having equation x is equal to 0. Now the total area of ellipse is again divided into 4 equal parts, as the area bounded by curve from 0 to 2 with x-axis is a shaded part. The required area is a 4 times this shaded part. From figure we can say that the required area A is equal to 4 times area from 0 to 2 bounded by curve with respect to x, y dx. So we put the value of now y, which is the under root of, which is a 3 by 2 under root of 4 minus x square dx. Now 3 by 2 is a constant, we so take it outside, as 4 into 3 12, 12 by 2 is equal to 6 multiplied by integration 0 by 2 root of 4 minus x square. Now this is again radical form of root of a square minus x square, having integration x by 2 root of a square minus x square plus a square by 2 into sin inverse x upon a, as a is here 2. So we take the integration as x by 2 under root of term, that is 4 minus x square, plus a square by 2, that is 4 by 2 into sin inverse of x divided by radical 2 from 0 to 2 as given limits. Now simplifying this, as we know the upper value of first term is 0, as upper limit 2 square 4 plus, and lower second in term second 4 by 2 is a 2, and sin inverse of 2 by 2 is a 1, which is a pi by 2. So upper value is 0 plus 2 pi by 2, and minus, as lower value lower limit is 0, first term will take 0 value as x is in product, and in second term sin inverse of 0 is always 0, so this product is 0, so lower value is a 0. Now simplifying this, as 2 get cancelled, we get the answer 6 pi square unit. Find area under curve y is equal sin x from x is equal 0 to x is equal to 5. As in given example, y is equal sin x is the equation of curve, and having values of x is equal 0 and x is equal to 2 pi. Now we can evaluate this area directly, but if you directly evaluate this area you get the answer 0. Why this happen? As here the curve is a sin x is a standard curve, as we can plot sketch standard curve. We here plot standard curve of sin x. On here on x-axis we take the angles as x is the angle in radian form, so we take the angle in unit 0, then pi by 2, that is 90 degree, and then that means 1 unit is a 90 degree. So next point will be pi, next point will be 3 pi by 2, that is 270 degree, and 2 pi is again last point. Continuing by this, as we know sin 0 is always 1, 1 2 2 3 we have to put, actually sin 0 is always 0, sorry, and pi by 2 is a 1, then sin pi is always 0, sin 3 pi is a minus 2, and sin 2 pi is again 0. So plotting the curve, continuous curve, we get the curve which is a curve of sine curve, which is called curve of sine or sine x. Similarly, if we plot curve of cos x curve, then it will be like this. That means at cos 0 we have the value 1, cos 90 is a 0, cos pi is a again minus 1, cos 3 pi by 2 is a 0, and cos 2 pi is again 1. Okay, remember these two curves. This is a cos curve and this is a sine curve. Now you can observe in sine curve, the area under the curve is divided into two parts. As we see here, the area under the curve from 0 to pi is below curve, and pi to 2 pi is above curve. The both directions are opposite and these are equal areas. So by getting integration from 0 to 2 pi, we add and subtract same area, so it came 0. Now actually area is always positive, but by taking direct integration from 0 to pi we get answer 0. So to find required area, we take area from only 0 to pi, and the required area from figure, we can say that from figure required area A is equal to 2 times this shaded area. Okay, and this shaded area is integration from 0 to pi bounded by curve with respect to x-axis. Now 0 to pi, y is given as a sine of x dx. Now simple integration, sin x as integration minus cos of x with limit 0 to pi, as I missed 2 here. So now 2 as take minus sign out of bracket, so I get minus 2 on out of bracket, and in bracket I get only cos of x with limit 0 to pi. Now minus 2 into upper limit as a cos pi has a value minus 1, minus lower limit as a 0, cos 0 has a value 1. Now minus 1 minus 1, minus 2 into minus 2, 4 square unit is our answer. Area of loop of curve y square is equal to x square 1 minus x. Actually loop of curve is again any standard form of curve which is a bounded curve, that means it bound the area. Now here given curve is y square is equal to x square into bracket 1 minus x, as this is a implicit function as containing both x and y's function, so we have to simplify this into form of explicit function. For that we take only square root on both sides. On left hand side we get y, and on right hand side there is a product of x square and a bracket, we this bracket, so we take separate square root. As x square has a square root x, the bracket contains subtraction, so we can't separate take each term's root. We take the root of the subtraction, that is we get root of 1 minus x. Now I put this as a number 1. Here the limits of the equation, limits of the area is not defined, so for that we take y as a 0, so we get equation as putting y as a 0 on left hand side of given equation, or which equation we simplify. Both equation are same, and from both equation we get the same value, but we use equation number which we have given, as it is a free of radical sign. As you observe here, in equation which we simplify having root sign. Root sign means it contain a radical or index fraction or in form of here 1 by 2. So generally to factorize polynomial we need a rational we need a polynomial which is a free of radical signs. So putting y is equal 0 in given equation, we get on left hand side as x square into 1 minus x is equal to y 0. Now simplifying we get the two factor, first factor x square which we take 0, and second factor 1 minus x is equal to 0. That means x is equal to 0, and by simplifying this we get the value of x is equal to 1. Now these x values are the limits of the given a required area. But as this, I say this loop is a one type of standard curve. If we plot the given loop, actually loop is a figure which is a start from one point and after symmetric form it came to end on that point. As it is a loop of the given curve, so this curve is a continue. So like this we can define figure of loop. Okay, observe this, as this curve start here, as it came after some time here, so this form which is a bounded is a loop, and this bounded region form a area which we have to here find. Now as this loop of curve has a x coordinate 0 and x coordinate 1, it means maybe it start from 0 and end at 0, or maybe at 1 and end at 1. We take here a loop which start from 0 and which is symmetric. It cut x-axis at again point 1 and again it came like this. So this is the loop. As I plot the parallel line to y-axis at this point where it cut the x-axis at 1, as the equation x is equal to 1. As this is the y-axis, so its equation is a 0, x is equal 0, as we start from the loop. Now from figure we observe that the area bounded by loop is again divided into two parts, which is above the x-axis and below the x-axis. Again what happens if we take direct integration from 0 to 1, we can only get the one side, as we find area bounded by curve with x-axis from 0 to 1. But from figure we want an entire area or required area, then we have to multiply that area by 2. So from figure required area A is equal to 2 times area bounded by curve from 0 to 1 by curve with respect to x-axis. So 2 times, remember if we don't take 2, then the area is only the shaded area, but we want to find entire area which is a double the shaded area. So we take 2 times integration from 0 to 1 into y is nothing but here given by x under root of 1 minus x into dx. Now we have to find the integration of this expression. As this is a definite integration, we use here properties of definite integration. As we know, by property x replaced by addition of limit minus x, that is 1 minus x, the value of integration does not change. So by using this we take integration from 0 to 1 and replace x by 1 minus x in integral. So in numerator, in integral, as first term x is a bracket of 1 minus x is now, and in root as 1 minus x is given, so 1 minus as x is replaced by 1 minus x into d. Now simplifying this as 2 from 0 to 1, 1 minus x is the first term, and in root what happened, actually plus 1 minus 1 get cancelled and minus minus we get plus x. Actually root of x is represented by x raised to half. As we never take radical sign in integral, they are converted into index form. Actually root x is x raised to 1 by 2. So instead of taking root x, I take x raised to 1 half. Now multiplying this bracket by x raised to 1 half, we get the values of 0 to integration from 0 to 1. The first value x raised to half and minus in second x into x raised to half, adding index 1 and half, we get the x raised to 3 by 2. Now taking the integration simply, as 2 is a constant which is a multiplier of this subtraction in integration, so by taking bracket we take separate integration of both the term. The derivative integration of first term x raised to half will be x raised to 3 by 2 divided by 3 by 2, as this is a power function, as 1 half plus 1 is a 3 by 2, so we get the integration which has a limit 0 to 1, and minus, and in second term as x raised to 3 by 2 is again power, therefore x raised to 3 by 2 plus 1 we get the 5 by 2 as index, and denominator we get 5 by 2 with limit 0 to 1. Now by putting the limits only we get the required answer. Okay, as 2 into bracket, as upper limit is a 1 and these are the term in power, so we get the upper value always 1 and lower limit is 0. Again term of x is a term of power and 0's power is 0, so lower value is a 0. So simplifying only bracket, as 3 by 2 is a constant, so we take it outside the numerator, denominator 2 came into numerator, and we get 2 by 3, as upper value is 1 and lower value is 0. And in second also 2 by 5, again same, upper value 1, lower value 0. By simplifying this only, 2 into bracket we get 2 by 3 minus 2 by 5. Now by cross multiplication, 5 into 2 10, 3 into 2 6, 10 minus 6 is a 4 by 15, and the final answer will be 8 by 15 square unit.